Okay, today we're simplifying our operations with square root expressions, but now we got a game changer. We have 5 times the square root of 3, and now we have a plus sign, and then 6 times the square root of 3. Now what people are going to think they do is they add the 5 and the 6, that's 11, and then they add the numbers under the square roots and put square root of 6. Nope, it doesn't work that way. Addition is something completely different, okay? I want you to take some notes down here. First, you have to match the square roots, okay? You have to try to match the square roots. That means match means they have to have the same square roots. When these already match, square root of 3, square root of 3. Okay, so these already match. And after they match, if you're able to get them to match, okay, you add the coefficients. But you can only add the coefficients if the square roots match, okay? Add the coefficients after the square roots match. Okay, so the square roots match. So put your matching square root down just one time. Okay, so now you add the coefficients. 5 plus 6 is 11. Okay, that's all you do. If they match, that's all. That's what this is. That's the name of the game. Now we have 7 times the square root of 2. If you run across a minus, make it plus negative, and then so you do have the plus. So look at your square roots, they match, so they're both in the form of square root 2. Both the square roots are square root of 2, so you write square root of 2 down, and then you add the coefficients after the square roots match. It's like adding like terms. 7 plus negative 4 is 3. Okay. Alright, 10 square root of 3 plus square root of 3. Now, so you got times, you have the plus, and then the square root of 3. Now, the square roots do match. Now this is an instance where you have a 10 coefficient and you would put a 1 coefficient right there. Okay, so you can see what you're adding. Because there is a coefficient there, it's just 1. You will have to put the 1 there yourself if there's no coefficient. So 10 plus 1 is 11. So 11 square root 3. Now, 7 times the square root of 2. Then I have the subtraction operator, so plus negative. And again, square root of 2. So we have square root of 2, those match. And then we have a 7 coefficient here, and we put a 1 there. So we're adding 7 to negative 1, which is 6. So 6 square root of 2. Now those are easy, okay? Pretty much a walk in the park. But what happens if the square roots do not match? Well, you're going to put in your operators. 5 times the square root of 2. Minus, make it plus negative, and put a 1 there so there's a coefficient. Now clearly the square roots don't match, so when they don't match, you're going to make a table over here, and on one side you're going to put 5 times the square root of 2. Then on the other side you're going to put what you're adding, which is negative 1 times the square root of 50, okay, because that is a times. So this is how you're going to handle this. Okay, so 5 times the square root of 2. Now the square root of 2 is irrational. Okay, you need to simplify both the square roots if they do not match. Okay, so IRR. So you're going to drop this 5, and then you're going to put times, and then you're going to put divided by a division sign after the 2, and then square root times square root. Okay. Alright, so 5, okay, so we're at 2. So the only thing 2 could possibly be divided by is 1. Okay, so 1 and 2. And the square root of 1 is 1. So when the square root ends up as 1, we really don't need that. So it's just 5 square root of 2. You don't multiply anything. So really this just stays the same. Okay, it stays the same as it was originally. Now, how about the square root of 50? Now, 50 is irrational, okay, so IRR. So we put the division sign, we bring the negative 1 down, and then we try to write this into 2 square roots. Square root times square root. So 50, we'd start 50 divided by 49. Nope. Divided by 36. Nope. Divided by 25 works. 25 and 2. Don't put 25 and 5. It's 25 and 2. The square root of 25 becomes 5. Okay, so we have a coefficient of 5. So we have negative 1 times 5 times the square root of 2. Well, now we need to take negative 1 times 5, and that's going to be negative 5 square root 2. Okay. So, negative 5 square root 2. So now you're where you want to be. The square roots match. I write the square root of 2 down, and then I add the outside coefficients. Okay. 5 plus negative 5 is 0. Now if you end up with a 0 coefficient, then the whole thing is 0. Okay? That's if you end up with 0. Okay, next one, we have 2 square root of 300 plus 7 square root 27. So we got times here, then the plus, then times. So I have that plus sign right there. So when I have the plus sign, I got to make sure that the radicals match and that the square roots match, and they do not. Okay, so since they do not, I take the expression I have over here, 2 times the square root of 300, and then the expression here, 7 times the square root of 27. Okay, so 300 is an irrational square root, so I put the IRR label, and right after I do that I put divided by, a division sign. Now I drop my coefficient of 2, I just carry that down, and then I'm trying to rewrite the 300 into 2 multiple square roots. So 300 would start at 289. That's a decimal. 256, nope, that's a decimal. 225, that is a decimal. 196, that is a decimal. 169, that is a decimal. 144 is 300 divisible. Nope. Nope. 300 divided by 100 is 3. So I fill in those 2 square roots with 103. So the square root of 100 equals 10. Okay. So we now have 2 times 10 times the square root of 3, and then 2 times 10 gives me 20. So we replace 2 times the square root of 300 with 20 square root 3. You can put a dot there if you want. And then plus, now we try to replace the 27. 27 is an irrational square root. So I put IRR, put the division, bring down the 7, and split that into the product of 2 square roots. Remember, this times this has to equal 27. But you want the first factor to be a perfect square. So 27 divided by 25 is a decimal. 27 divided by 16 is a decimal. Divided by 9 is 3. So you put 9, 3. And then coincidentally, the square root of 9 actually turns into 3. Okay? So we have 7 times 3 times the square root of 3. So 7 times 3 is 21, and then square root 3. So you replace this with 21 square root 3. Now that I have simplified, okay, the square roots match, and we have the square root of 3. So then I add the coefficients. 20 plus 21 is 41. It's similar to if you have 20x plus 21x. Okay, you write x down and just add the 20 and 21. Well, having a common square root is like terms. It's just adding like terms. Okay, next one. 4 square root 24. That's times minus, but that would be plus negative. Okay, negative 3 times the square root of 96. So with that addition, we want to look at our square roots, and they do not match. Okay, so we need to make this table over here to get them to match. So on one side we put 4 times the square root of 24. On the other side, negative 3 times the square root of 96. Okay, so the 24 is not a perfect square, so it's an irrational square root. We bring down the 4. And we put times square root times square root. So I take 24 divided by. Well, first I'm going to try 16. Nope, that's 1.5. Then I'm going to try 9. Nope. Then I'm going to try 4. 4 and 6, there you go. So the square root of 4 turns into 2. So we have 4 times 2 times the square root of 6. So 4 times 2 is 8, and then square root of 6. So this is replaced with 8 square root 6. This and this are the same thing. This is the simplified form. Okay, 96 is not a perfect square. Okay, so you put IRR, then negative 3 times square root times square root. Okay, so 96 divided by, you'd start with 81, no. 64, no. 49, nope. 36, nope. Nope. 16 and 6, okay? So you put 16 and then 6. So the square root of 16 equals 4. So you have negative 3 times 4 times the square root of 6. Negative 3 times 4 is negative 12, and then square root 6. So now I have negative 12 square root 6. So now the square roots match, which is what we need for adding, okay? And then 8 plus negative 12 is negative 4. Okay, now negative 2 square root 10, that means times, plus 6 square root 40. Okay, so there's adding. The square roots do not match like they were on the first page. So I put negative 2 times square root of 10, and then 6 times square root of 40. Okay. Alright, so square root of 10. 10's not a perfect square. We put the IRR label, and then the division sign, and then negative 2 times square root times square root. So 10. 10 divided by 9, decimal. 10 divided by 4, decimal. 10 divided by 1 is 10, so 1 and 10. And then the square root of 1 is 1. We don't need the coefficient of 1, so that's just going to be negative 2 times the square root of 10, and then you don't multiply anything. So we just keep that the same. Okay, that was already in simplified form because the only thing that was divisible by was 1. Okay. And then the square root of 40. That 40 is irrational. So divided by, and then you start 40. So 40 divided by 36, decimal. 25, decimal. Decimal. Divided by 9, no. 40 divided by 4 is 10, so I put 4 with 10. And then the square root of 4 turns into 2, and now we have 6 coefficient times the coefficient 2 times the square root of 10. So we multiply the outside coefficients. That's going to be 12 square root 10. Okay. Now your square roots match, and you have like terms. Square root of 10, negative 2 plus 10 is 10. Okay, 10 square roots of 10.